So today we're going to be looking at tangent waves. And now this is an introduction to how does a tangent wave look and what are some basic characteristics so we can graph it going forward in the future. Now, if we remember, tangent waves are going to be based off that geometric or old school relationship of opposite over adjacent, which we will then have converted into the unit circle. If we remember the unit circle, we know that tangent waves have this nifty little feature that every time we loop around, we know opposite over adjacent is tangent, which is in essence going to be our y value divided by our x value. And as we creep our way around the unit circle, we'll notice that our x value disappears at two different points on the graph. Actually, let me do this in red so we can spot them a little better. So at the top and the bottom, my x value disappears. So we're going to introduce something called repeated asymptotes. This function is going to bend towards infinity twice every time it loops around, which, because it has to do that 2 times every time we go around a circle, our period for the tangent function is going to be changed from normal. Normally, we would expect a period to be repeated every 2 pi units, but a tangent function is going to be repeated every pi units. So let's go ahead and take a look at the first one and see how this would be graphed. So I'm going to zoom in just a bit. Number 1, we're going to state the amplitude, period, and any transformations that are applied to each one. The first thing we know is that because we're moving towards infinity, the amplitude doesn't really exist, but it does dictate how stretched out the graph appears. So our amplitude for all tangent functions really does not exist. The period, though, will change just slightly. This one is a basic tangent function, so I know the period is going to be pi over my b value, which is 1. So my period is every pi, which means the function is going to repeat itself every pi units. The last thing is there's no transformations that have happened. So I need to set up some values. I know that it repeats itself every pi units, so okay, where do I start? Well, again, for the first one, and we're going to modify this as we go forward, we're going to base ourselves off the unit circle. And so let's take a look at a few values. As we work our way around and we start at the 0 function, or at the 0 value, what is my y over my x value? What is the o divided by the a, or the y divided by the x? Well, in this case, my x is 1 and my y is 0. So I know the function is going to start itself off at the 0 value. I also know that by the time it hits right here, my x value will disappear and I'll be undefined up here at the top, which is halfway to the value of pi, where it looks like at pi, again, I'll be at 0. Boom. So I have a 0 and a 0, which makes sense because this will repeat itself every pi units. And directly between those two values at pi over 2, I'm undefined. So I'm going to crank an asymptote right there. And this is going to be repeated across the entire spectrum of the graph. So I have an asymptote over here, 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 and across the entire graph. I also know that every pi units, my tangent function repeats. So I have all of these zeros. Well, now the thing is I need to figure out how is this graph curving, because I go towards an asymptote, I'm going to curve up or curve down. So I'm going to take a random sample of something directly between this point and this point, so directly between my 0 and my undefined point, and see what the values are. Well, I know the y divided by the x at a 45-degree angle, which is directly between these two, is going to be the equivalent of 1 over 1, which is going to be a 1 value. So if I graph that on the chart, what I see is that the graph will curve up. So each one of these will curve up as it approaches the asymptote directly on its right. And so if I want to see on the other side, I would just take a different hypothetical point. Let's use the purple on this one. And see what direction it would take here. I know here my y value would be negative, my x would be the same, which would be a -1. So I know the graph is going to curve down through that point right there. Boom. And so we know that this is going to be our basic tangent function. We're going to be modifying this as we go forward. So that is the graph of tangent of x. Let's take a look at the next one. So number 3, our first modification comes in not the amplitude, but in the period. I know the period is going to be pi over b, and in this case, my b, let's see, the tangent of 1 over pi times x is going to be pi over 1 over pi. We can see by factoring that out a little bit, it's 1 over pi. Keep change flipped, that's pi times pi, or pi squared. So the graph has not been shifted, moved, or anything like that, so I know it will start at 0, and I know the next point is going to be at pi squared where it repeats at that value. So I'm going to come over here and I'm going to say, okay, on this graph, where is pi squared? Well, if we take a look, let's see. Pi squared is going to give us a value of roughly 9.8. So I need to figure out where on this graph is 9.8. I'm going to take a guess and say, okay, well, what is 3 times pi? 9.42. I know I'm going to repeat myself just beyond that. And so this graph is going to repeat itself directly between these things. So let's see how far. I have 1, 2, 3 pi, which means roughly 1.5 and a little bit further is going to be where my asymptote lies. I know I haven't adjusted the vertical orientation at all, so this graph is going to curve up towards the asymptote, which means, again, on the other side, it's going to curve down. And so we can see between the two graphs how that period has changed the overall shape of the graph. What were relatively tall and thin shapes by a normal tangent function, by dividing by some number b, what we've done is we've stretched out that graph quite a bit. Awesome. So that's going to bring us to our next problem. And our next problem is going to be a graph that in this case has been shifted. We also have a number up front, which means that there will be a sort of vertical stretching. So let's go ahead and let's take a quick look. For this one, I know my period is going to be pi over b, which is pi over 1, which is just pi. But I have shifted to the right. And I've shifted to the right by pi units. So I know my point that was originally at 0, 0. In fact, I'm going to kind of draw a ghost of a shape right here. I know that this is where my original graph was, where I had an asymptote right there, and I had an asymptote right there. This is moved over by pi. So I'm going to take the starting point and move it over by pi, which conveniently falls into exactly the next period, because we know that if we had drawn this shape, it would repeat itself every pi units. So this rightward shift by a pi value didn't actually change the shape of our graph at all. It just shifted everything over artificially. What will affect our graph is that 3, which means that this graph doesn't curve up slowly anymore. That 3 is going to stretch it out much faster. In fact, at the value directly between there, it won't be at -1, it'll actually be way down here. So it's stretched further than this, but again, this is just a sketch of what's going on. So transformations, we have period, we have a right by pi units, and we also have a stretch, S-T-R-E-T-C-H. Forgot I spelled stretch for a second, by a value of 3. So my graph is going to be much taller and skinnier. So pi, every pi units, it repeats itself, which very conveniently, as we said, doesn't change where the graphs are. It doesn't change where the asymptotes are either. All the asymptotes still exist directly between these 0 values. But it does change how quickly those asymptotes, or how quickly the graph tries to get up as it moves towards the asymptotes. What was going to be a very gradual curve with a 3 is going to be a very steep curve. Awesome. So let's bump off to the next one. Now, the next one, we've got a couple different types of transformations, and this one is a little trickier than the others. On number 7, what we see is the fact that we have a pi in front of the x. So I know in order to get my period, I'm going to have to factor out whatever is in that value, or whatever is in this set of parentheses, away from the x. So if I factor out a pi, I'll get x minus 2. which tells me most of what I need to know. Tells me my period is going to be pi over b, which in this case my b is going to be pi, so pi over pi is 1. I repeat myself every one value. So with this 1 unit, we'll see the fact that we have, instead of pi units, which is 3.14, it'll be 1, 2, 3, and then I'll have, before the 6, probably a 4, 5, 6, 7, 8, 9, 10, 11, 12, and we'll see the graph repeat itself on a scale that's not really what is shown. The other thing that we're going to see is we're going to see the fact that it has been shifted to the right by 2 units and up by 1. So what was starting out right here is now over 2 units and up 1 unit. So my origin is now moved over and up. Now, because the graph hasn't changed in that aspect, I still know that I'm going up and down through that, but we're going to take a peek at where the asymptotes fall. So if my period is every 1 unit, I know every one of these blue tick marks, I'm going to have to put another point because they're every 1 value, which means I'm going to have a lot more of these waves in the same space as I normally would. We also know that in between every single one of these points is going to be an asymptote. So this is going to be a very crowded, very tightly packed graph. And as we get through all this, we know that the graph hasn't changed orientation, so I know that it's still going to be curving up and down, but that point of inflection is no longer on the axis. It's just moved up a little bit, which for our hand-drawn graph shouldn't really matter too terribly much, but the idea is that we have a lot of waves all packed in here very tightly. I'm gonna go ahead and draw that edge of one right there. And then we have it over here as well. In fact, we could, if we wanted to, draw some more. But I think at this point we get the picture. So we see the graph has repeated itself much more often, and it's on a scale that's not what's shown. So I want you to take everything you've seen so far, and I want you to attempt number 9 on your own. Pause the video, unpause it when you didn't see it while you did. The only thing that you want to keep in mind as you try this on your own is going to be that negative sign. What do you think that negative sign is going to do to our graphs that we've seen previously? So go ahead and take a shot at it, unpause it when you're done, and check out your work. Okay, so now that you've had a shot at this on your own, I know that this one I'm going to have to factor out that pi again, which is going to leave me with an x minus 3. So I see that my period has again been affected. I know if it's pi over b, that's pi over pi, my period is 1. So again, I'm going to have to look at this graph and rewrite the scale so that it's every 1 unit, just because we're going to have to shift everything over. So if that's 3.14, let's call that 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, roughly there. There we go. So we have our scale drawn. Next thing, we're going to look for any shifts. I know that this has been moved to the right by 3 units. So I'm going to come over here and I'm going to say, hey, what did start at 0, 0 is now over 1, 2, 3 units. There's no vertical shift, so I know I'm going to have a point right there. The next thing I'm going to take a look at is that -2. I know I have a stretch, so this is going to be a much skinnier graph, although with the periods this is going to be a very skinny graph because it's already tighter. And the last thing, that negative, I know that this has been flipped, which means instead of going up and down and being a slowly upward curve, it is now something that's going to be curving from the top and all the way down. Awesome. So let's see if we can't emulate that on our graph. So if I have a period of 1, I know on each one of these things, I'm going to have a 0 point. Which again, we said with that 2, this is going to be a very crowded graph. I know in between each one of these, I have an asymptote. The next thing I know is instead of curving up, I'm curving down. Not only am I curving down, but with that 2, I'm curving down much faster. So this is going to be almost a vertical line. So let's just pick one at random. So instead of curving up like we normally do, we are going to be curving down. In fact, if I were to draw a shadow of the old graph would have gone up and down this way, but we went ahead and we flipped it upside down. So this 2 means that it's just curving through each one of these things. Perfect. And now, after we draw several more, so that we can fit all of these on the same graph, that is how we draw a tangent wave. We notice the tangent wave has very basic characteristics, nothing too terribly crazy. It does have a lot of asymptotes, it has a lot of points, and it's not going to be something that we can just draw without picking up our pen many, many, many times. So, there we go.